Here we have a function f of x, and then we have a secant line. Now, what is the slope of the secant line? Well, the slope of any line is just the delta y over the delta x, or the change in y over the change in x. If we look at the 2 points at which the secant line touches the function, it's at a point where x is equal to a number a and x is equal to a number b. So within that interval, and recognizing that this interval is equal to your delta x, or your change in the x values. Now, what is the change in the y values? Well, at this point here, this is f of a, this is f of b. Now we could see that this interval here is your change in y. So now the slope just becomes f of b minus f of a divided by b minus a. Or in other words, we could write f of b minus f of a all over delta x. And that's the slope of the secant line. In calculus, we want to know when this secant line becomes a tangent line. And that's when this point fb approaches point fa, or f of a. And that means that the x values b gets closer or approaches the x value of a. In other words, delta a gets a lot smaller. So in other words, this delta x has to approach 0. So what that means is that the slope of the tangent line is equal to the limit of that function, or of that slope fb minus fa divided by delta x as delta x approaches 0. That is the slope of our tangent line. Here we're seeing the point getting close and close to point A. That means that the slope of the secant line is changing into the slope of the tangent line, and that's what we see here. It becomes tangent. Now it becomes tangent because the slope of the secant line we're considering is that delta x gets smaller and smaller and smaller until it approaches 0. As you can see here, there is no delta x anymore. That delta x is 0.